Okay, so we're going to pull up the notes and we're going to continue doing notes 35. Okay, so last week on Thursday, we did the first part of this, which is just the first problem. Okay, so that was the one-step problem going from particles or going from moles to particles, which means to atoms, molecules, or formula units, or from going from atoms, molecules, or formula units to a mole. So just either one back or forth. Now we're going to put the 2 days together from last week's notes. So notes 34 and 35, meaning you could go from mass, so having to calculate molar mass from the periodic table, grabbing their masses and adding them up, or you could have to use this conversion factor with a 6.02 times 10 to the 23rd, one of these particles over a mole. You're going to have to use both. So both conversion factors from both single step days, now we're going to put them together into a 2-step problem. And it does, basically the only hard part is knowing when do I use each one. You know you're going to use both. You're going to use both conversion factors. You're going to use this one, you're going to use 6.02 times 10 to the 23rd. You're going to use that one, but you're also going to use the conversion factors that we did with molar mass, where you had to have their mass, and it was their mass in grams over 1 mole. So you're going to use both and to be able to get to the right unit. Okay, so knowing that, let's just begin. Because honestly, with moles, there is no way to begin other than to just begin. It is just a math problem. To start it, you start it like all the rest of them. So I'm going to look at what is given. I was given 1.625 times 10 to the 22nd sodium chloride, and that is in a CO. Formula units. So that's my unit, formula units. And I want to I'm going to go from formula units to grams. Okay, so I mentioned this in our last notes video, but I need to remind you. How do you know it's a 2-step problem? So when you get to your quizzes or your tests, how can you differentiate from last week's where we did 1-step problems from this week doing 2-step? How do you know when to do which one? In these problems, you are given a particle, so a formula unit, an atom, a molecule, and you're asked to get to a gram. Or you are given a gram and asked to get to a formula unit. Okay, so either way, you are going from particles to grams or grams to particles. What is different about that is, like this problem here, you are going from particles, which in this case atoms, to moles. Okay, so moles is part of the question. Same thing in our previous one with molar mass, you are going from grams to mole. So mole was part of the question. So that's how you know. If moles is part of the question, it is a 1-step problem. You only have to do 1 step if moles is part of the question. If moles is not a part of the question, like this one you were seeing here, I'm going from formula units, which is a particle, to grams. So mole is not even mentioned, but you know this is the mole unit. So we're gonna have to get to a mole at some point in time. That means it's a 2-step problem. So when I'm going from particle to gram or vice versa, and mole is not mentioned, then it is a 2-step problem. So I'm going to go ahead and set it up knowing it is a 2-step problem. Did I just solve the problem wrong? I'm pretty sure I did. Let's fix it. Well, now it doesn't look like a R, but it is. All right, here we go. So like always, we're going to start with what's given. 1.625 times 10 to the 22nd the formula units. So formula units of NaCl. That's what I'm starting with. Now we know in the calculator this is going to have to be in parentheses, so I'll go ahead and put them in parentheses. Now I already know this is a 2-step problem because moles was not mentioned in the question. So I'm going to go ahead and set up a 2-step problem. Might as well, I already know it's going to be one, and that will help me know where to move forward in this problem. Now, just like we've done before, whatever unit is on top must be the unit that goes on bottom next, because my goal is to cancel it. Okay, so I know that FU units are going to go there, formula units. And then I think, okay, what is it to? Well, what has everything been to in this whole unit has been to a mole. So a mole is always the other part, the conversion factor. It's a mole to formula units, it's a mole to atoms, it's a mole to molecules, or it's a mole to grams. It's always a mole to something. Now, what numbers go with these things? If we look at our conversion factors, again, I'm going to write them down here just so we can remember it. So it's either molar mass from the periodic table, which is in grams over 1 mole, or flipped upside down would be 1 mole over molar mass, or it's particles over 1 mole. And that number of particles is 6.02 times 10 to the 23rd. Now, which one are we dealing with here? Well, formula units is a type of particle. So is atoms, so is molecules. So I know that this is going to be this kind, not this kind yet. It's going to be the 6.02 times 10 to the 23rd particles. So in this, 1 always goes with mole. I know it's on, it's flipped. This example had mole on the bottom, this has mole on the top, but still the number 1 is what goes next to the mole. And what goes next to the particles is 6.02 times 10 to the 23rd. Okay, at this point, my formula units would cancel, but I'm left with moles on top. So if I calculated right now, if I put this in the calculator, I would have my answer in moles. But what it asked me for was grams. So I'm not done yet. I need to multiply again with something else to get it into grams. So now I have a new top. My new top is a mole that I want to cancel. So my new bottom will also be a mole because I want them to cancel out. And now we are at the end of the problem. I told you this is a 2-step problem. We're only doing 2-step problems. So obviously what's going to go on top is what I want to get to, which is grams. Okay, so this is like our problem that we had, the first set of notes, notes 34, molar mass to mole. So it's just this one. It's going to be this conversion factor down here, molar mass to 1 mole. Okay, so mole is on the bottom, just like shown there. So it's going to get a 1 because mole always gets a 1. And the grams is the molar mass. The molar mass of what we are dealing with, which is NaCl. So I need the molar mass of NaCl. So I cannot continue this problem until I have calculated the molar mass of NaCl. So I'm going to write that here. Molar mass of NaCl. And remember, to figure that out, I have to look up the mass of sodium, I have to look up the mass of chlorine on the periodic table and add them together. So when I look up the periodic table for sodium, it is 22.99. When I look at the molar mass for chlorine, it is over here at 35.45 and sodium over here. So I have 22.99 and I have 35.45 for chlorine. Okay, so we'll head back to notes. I'll write that down. It's going to be 22.99 plus 35.45. I've done sodium problems a lot, so I have this one memorized actually. It's 58.44 grams per mole is the molar mass for sodium. So I'm going to put that number up here, 58.44, and just like it says, grams per 1 mole. There we go. Now I look at my units again, and my moles have canceled there, top and bottom. So if I took the time to calculate right now, multiply the top and divide by the bottom, I'd be left with grams on top, which is what they asked me for. So I know that I'm ready to put this in the calculator. Okay. So when I put this in the calculator, any of these scientific notation numbers have to be in parentheses. And I'm going to multiply the top numbers, hit enter, then divide by the bottom. So kind of listen to what I put in the calculator. I put parentheses set 1.625 times 10 raised to the 22nd, close my parentheses. So that's that first part. I multiply it by 1. I don't really have to multiply by 1, but I'll go ahead and do it. That's what it says. And then I multiply it by 58.44. Hit enter. So that would be the answer for the top part. I don't erase my calculator though. I leave that answer in there. That's the top part. And now I need to divide by the bottom. Well, the bottom is 6.02 times 10 to the 23rd times 1. I don't actually have to multiply by 1. So I'm just going to, not do the divide by 1. But I do have to divide by the 6.02 times 10 to the 23rd. So I hit divide in my calculator, divide the number I just got for the top, hit parentheses, do 6.02 times 10 raised to the 23rd, and close my parentheses set. All right, and the big answer I get, actually it's small, is 1.58. So I get 1 point, I'm going to write that out a little cleaner, 1.58 grams. That's it, 1.58 grams of, well, if I wanted to really write it all out, I have a hard time getting this to look a little. 1.58 grams of NaCl. That would be the answer. There we go. Okay, let's practice one more. Erase this. There we go. And it says, how many oxygen atoms? Okay, this is where we wanted to change this problem. We used to take it this step further, and we're going to take this step out. So I'm going to change it right now in the notes. So you probably want to change this with me so you realize what I did. I'm going to say how many molecules of SO3, okay? How many SO3 molecules are in 125 grams, that's what I'm starting with, 125 grams of sulfur trioxide. Okay, so if I have 125 grams of sulfur trioxide, which is SO3, how many molecules do I have inside of it? So again, you're noticing, how do I know this is a two-step problem? Because they said you go from grams to molecules, grams to molecules. So grams to particles is when I know it's a two-step problem. Grams to mole, one-step problem. Molecules to mole, one-step problem. Grams to molecules, leaving moles out of the question, is a two-step problem. So I'm going to write down what they've given me, as always. They gave me 125 grams of SO3. I already know it's a two-step problem, so I'm going to set it up as a two-step problem. Now, if they've given me grams to start with, I know that grams is going to go on the bottom. To figure out what goes on top, we'll look at our previous example. I have 4 milliliters to a mole, I have grams to a mole. So what do I have? Grams to a mole. It's always something to a mole, and that number that goes in mole is always 1. How many grams are in 1 mole? Okay, so again, how do I figure out my grams? Remember grams, molar mass, that was the thing we did the first day. Molar mass, mass is a grams. So I have to figure out the molar mass of whatever I'm dealing with, which in this case is SO3. So I need to find the molar mass of SO3. How do I do that? I look at the periodic table. I add up 1s and 3 oxygens. So let's go see. So the molar mass of sulfur is somewhere over here. Where did you go? Is it covered up? Oh, yes, it's covered up by the words. I've lost it. Right here. It's 32.06. Okay, so 32.06, and then we know that oxygen from previous problems rounds up to a 16. So I have 32.06. 32.06. I remember 32.06. 32.06 plus 16. But remember, there's 3 of them, so it's really times 3. Like that. Okay, and then I'm going to add them up. So I have my calculator, 32.06 plus parentheses 16 times 3, close my parentheses. And I get the molar mass to be an 80.06 grams per mole. That's the molar mass of sulfur trioxide, or SO3. Okay, so that number goes with grams, 80.06. Okay. At this point, the grams would cancel because they're top and bottom with each other. Moles is what I'd be left with if I stopped and calculated, but I don't want moles. I want to get to molecules. So I need to do one more step. Now we have a new top, it's mole. So mole goes on the bottom. So I want them to cancel. I know it's a two-step problem. So the last thing, this is my last one, it's on top. So it's got to be the thing I want it to get to at the end, which would be molecules. What did they ask me for? So molecules up there. You can't shorten it to mole because then it will look the same as mole. So for molecules, sadly, you do have to write it out, molecules. All right, looking at my previous problem, so it's like this time up here, it's like that one, except for instead of formula units, FU, it is molecules. And again, with the mole, well, 1 always goes with it. So yes, it is flipped. Last time mole was on top, now mole is on bottom, but it's still the same. 1 goes with mole, and 6.02 times 10 to the 23rd is what goes with molecules, or particle atom formula units. That always goes with 6.02 times 10 to the 23rd. And I'm going to close out my parentheses set because I know that in the calculator I will need it. All right, if I stop right here, moles will cancel, and I will be left with molecules, which is what they asked me to get to, so I know I'm ready to calculate. So as I put this in the calculator, I'm going to multiply the top. I'm going to divide by the things on the bottom. So how it would sound is I would do 125 times parentheses, so I don't really need to times the 1. You can if you want to, but it's not necessary. Times 6.02 times 10 raised to the 23rd, close my parentheses. Oh, another thing. 23rd, close my parentheses. There we go. And I hit enter. Okay. After I have that answer, I'm going to hit the divide because I need to divide by the bottom. I'm going to divide by 80.06. So that's what's on the bottom. I could also then hit divide by 1, but I don't really need to do that. I know it's the same number. So what I come out with is 9.40 with me rounding it up. It actually was 399, but keep it at 2 decimal places. So 9.40 times 10 to the 23rd. If you have a times 10 or an exponent on your calculator, like make sure you are writing this down. Don't tell me it's just 9.40. That is nowhere near the same number as 9.40 times 10 to the 23rd. And I'm putting my units, which would be molecules of SO3. And that would be your answer. Okay. Now, if I scroll down, scroll down and answer this question down here. I'm just going to erase it enough. It's out of the way. There we go. It says, how do you know the difference between a single step and a multi-step? And remember, our multi-steps are really just going to be 2 steps. That's as much as we're going to do. It's 1-steppers and 2-steppers. So how do I know the difference between a single step and a single step and a 2-step mole conversion problem? Remember, if mole is mentioned in the problem, it is a one-step problem. If moles is not mentioned, if it is a gram to particle, so either way, particle to gram or gram to particle question, meaning they didn't mention moles, then it is a 2-step problem. And that's how you know. So you don't get them mixed up. All right. That is the end of our most important mole notes. We really just have a little bit more to do with formula writing after this and percent composition. But that was the big mole notes. Done it. Or did it. Better.